I need just a little bit of notation before we start. We're trying to, most of the exchange across that surface, across the top surface, is through turbulence. So we use this so-called Reynolds notation where the instantaneous vertical velocity through that plane would have a signal like this. If you put your chart recorder on that or plotted it out, you'd see lots of ups and downs, and with the instantaneous value, the deviation from the mean is the instantaneous value at any time minus the mean. And that's sort of standard in micrometeorology. Similarly for temperature, the instantaneous value minus the mean. And what we can define here, the variance, say for temperature, the variance of the temperature is the fluctuation squared, and that is simply the time average of the instantaneous value minus the mean. Now, clearly you don't know what the mean is until you define an averaging period. I mean, until I've drawn a line here and say this is my averaging period, I can't say what my deviations. And so this is just standard, first year statistics. Covariance is when you have two variables. In this case, vertical wind speed, instantaneous minus the mean, and temperature. And so in the simplest possible way of thinking about it is that the turbulence is moving air up and down. If the air here is a little bit warmer than the air here, then on average, as upward moving air is carrying slightly warmer air than downward moving, and you'll get a net movement of air, hot heat away from the lower surface up into the atmosphere. This could be, instead of temperature, CO2, water vapor. If this was water vapor and there's evaporation, then on average the air from here, it would be slightly moister than the air here, and that's the basic mechanism of the transport across that top surface.